Competitive exams employ word problems about averages as strategic filters. These questions are built around logical traps, specifically designed to burn time and induce calculation errors. By the end of this tutorial, we will isolate the 3 most common variations of these traps, break down their mechanics, and solve them step by step. To bypass these traps, we rely on one operational rule. We are taking the standard average formula and rearranging it. Our golden rule is total sum equals the average multiplied by the number of observations. Examiners construct tricks by hiding or overlapping individual averages. However, absolute totals are rigid. Calculating the total sum forces the true numbers to the surface. Let's apply this to our first scenario, the combined group. A class of 50 students contains 40% girls. The boys have an average weight of 62 kilograms, and the girls average 58. We need the final average for the whole class. Adding the 2 averages and dividing by 2, 62 plus 58 divided by 2, leads to a wrong answer. Because the groups are different sizes, their averages cannot be weighted equally. Step 1 is defining the exact head counts. 40% of 50 total students gives us 20 girls, which means the remaining 30 students are boys. Now we apply our golden rule. We multiply the 30 boys by their average weight of 62. That uncovers the total underlying weight for the boys, 1,860 kilograms. We follow the same logic for the second group. Multiplying the 20 girls by their average weight of 58 reveals a subgroup total of 1,160 kilograms. With 2 isolated subgroup totals, we can now find the true grand total weight of the entire class. Adding 1,860 and 1,160 results in 3,020 kilograms. Finally, we take that master total of 3,020 and divide it by our original count of 50 students. The math resolves to 60.4 kilograms. Operating strictly with total mass prevents the examiner from using uneven group sizes to skew your result. The second variation is the overlap problem. Here, a specific middle number is counted twice because it exists inside 2 overlapping subsections of a sequence. We establish the baseline truth first. For a sequence of 21 numbers with an average of 43, multiplying the 2 gives us a master sum of 903. The problem states the average of the first 11 numbers is 33. Multiplying those 11 slots by their average calculates a subtotal sum of 363. Then we calculate the last 11 numbers. With an average of 53, this second set of 11 slots results in a subtotal of 583. When we add these 2 subtotals together, they equal 946. This creates an artificial sum that is larger than our true master total of 903. The difference between these totals is caused by the 11th slot being counted twice. We subtract the master total of 903 from 946 to isolate that 11th number, 43. Comparing the subgroup sums against the master total identifies a single variable without solving for every number. Our final scenario is the data correction problem. Suppose an average height of 160 centimeters was calculated for 35 students, but one entry was recorded as 144 when it should have been 104. Most test takers would discard the initial average and start the entire 35 student calculation from the beginning. Instead, we find the flawed master total by multiplying the 35 students by the incorrect average of 160. This gives us 5,600. To save time, we will ignore the 34 correct data points and deal exclusively with the net difference of the error. We remove the incorrect 144 and add the correct 104. This leaves us with a net difference of -40. Applying that -40 directly to our 5,600 total corrects the sum of the entire dataset to 5,560. To find the true average, we divide the corrected sum of 5,560 by the original 35 students, resulting in 158.85. Using the net difference isolates the error from the rest of the data. This corrects the average using only the changed values, bypassing the standard process of summing and re-averaging every individual point. You now possess the logic frameworks for the 3 most frequent average-based tricks found in competitive exams. While the numbers will vary, the mechanical steps for the combined group, the overlap, and the data correction problems remain consistent across these side-by-side frameworks. To build proficiency with these shortcuts, complete the practice sheet linked in the description below. Mastering these frameworks allows you to reach the correct answer and recover time for more complex sections of the exam. Subscribe for more tactical problem-solving frameworks.